Hello everyone, welcome back to Study Crunch. Now in the series of signal and system, we are on class 9 and we'll be starting off with different types of signals. There are different signals, that is impulse, ramp, parabolic, step signal, and then triangular. Now let's look at them one by one. We'll also be discussing about the properties. First of all, starting off with unit impulse signal. It is also known as direct delta function. Its value is 1 at t is equal to 0. When we integrate this signal, we'll be getting 1, that is delta t dt is equal to 1 when we are integrating it from minus infinity to infinity. Let us prove this. Suppose we have a signal that has value of length as 2a, 1 by 2a, and the height is 2a, right? So now on integrating from minus a to a, that is from minus infinity to infinity, we'll be getting the length into breadth as 2a into 1 by 2a, which will be equal to 1 only. So delta t is equal to 1. It will be actually an increasing infinity function at 0, as it is a property of time compression. Now we'll be looking at some properties of impulse signal. The first property is that the area is equal to 1. So area under the curve, or say area, is equal to 1 when we solve for this. So it has a unit area, it is a unit area signal. Second property, the weight or the strength of the impulse is the amplitude. So if we have A naught as the amplitude of this signal, then the weight or the strength of the impulse signal is equal to A naught. Property third, that is, if we integrate the delta signal, we'll be getting a step signal, that is ut. Property number 4, delta t is equal to delta of minus t, that is time reversal signal. If it is time reversal, then it will be an even signal. So remember, if we time reverse the impulse signal, it will be an even signal. Property number 5, at t is equal to 0, the magnitude is infinity. So this will keep on increasing. That will be equal to neither energy nor power signal. So this is neither energy nor power. Then property number 6 says, if we time scale the signal, that is delta t is equal to delta t minus t naught, then also it will be an increasing magnitude function. Property number 8, if we multiply two signals, that is x of t into delta t minus t1 and x of t1 delta t minus t1, these both will be equal. Then yt is equal to 2t square into delta of t minus 3. This is the suppose example. So we put t is equal to 3. On solving, we'll be getting 18 delta t. So here 18 will be the weight and delta t is the function. Now value of yt is equal to cos of 4t into delta 2t minus pi. We know that t minus pi by 2 is equal to t. Then this part will become 80. When we write this part as 80, then this will be equal to 1 by 2, that is magnitude of 2 into delta t minus pi by 2. This was the property number 7. Property number 9, area is equal to x of t1. If we have a signal that is x of t into delta of time scale function, that is delta t minus t1, then it will be a constant equation. So it will be x of t1. Then we have an example. If we have I is equal to 2t square minus into delta of t minus 4 dt, then in these type of signal always check the limit. So it is from -2 to 2, but the value lies outside 2, that is 4. So the result is equal to I naught, or I is equal to 0. Always check the value of the limits. So suppose we have I is equal to -10 to 10, 2t square delta t minus 4. 4 will lie between the limit -10 to 10. So from property number 8 and 9, we can say that I is equal to 32 on solving this equation. Property number 10, x of t into the differential equation, then it is applicable that it will be equal to 0 or a finite value. For example, I is equal to cos of pi t into d square delta t minus 1. So we know that the cos pi t of this function will be having some finite value, so we can directly use the formula. So by solving it from the formula, we'll be getting I is equal to pi square. Now let's move on to some questions. I is equal to -5 to 4 x of delta t minus 5. So we know that -5 to 4, but the value lies behind that, so it is 5. T minus 5, so t is equal to 5, that will be outside the limit, so I is equal to 0. -5 to 4 delta t minus 2, so t lies into, that is -5 to 4 limit, so it will be equal to 1. Next, x of t is equal to sin t into delta 2t minus pi. We'll be having sin t as the first function, and this is the impulse function. So delta of at is equal to 1 by a modulus of a into delta t. So again solving this, we'll be getting half of delta t minus pi. Now moving on to next question, that is 4. We have the limit as -infinity to infinity. Cos of pi t delta t minus 2 3 delta t plus 1 in plus sin pi t into delta 2t minus 1 dt. So again solving, we'll be solving it in 3 parts. So I1 is this much part, I2 is 3 delta t plus 1, and sin pi t is third part. Solving for first, this is the property. So on solving by the property, I1 is equal to x of t1. So we have cos pi of 2, so it is 1, as cos 2 pi is equal to 1. Now I2 is equal to 3 of delta t plus 1 dt. So we know that delta t plus 1 is 1. So I2 is equal to 3. I3 is equal to sin pi t into delta 2t minus 1 dt. So from the property again, we'll be writing 1 by modulus of 2. So this was another question. Now we'll be moving forward to the unit step signal. Basically, unit step signal is known as heavy side step function. Ut is equal to 0 at t is less than 0. We don't have value here, but we have the value on the positive axis. So the property says that if we have ut plus u of minus t, then on adding both, we'll be getting a function that is progressive, or it is infinitely extended to both the sides. So on adding these two, we'll be getting at 0 there will be 2. The magnitude becomes 2 because we have u of t and u of minus t. So at 0, we'll be having a value that is 1 plus 1. So this is known as the Gibbs phenomena, which is a discontinuity in the signal. So Gibbs phenomena states that at a point of discontinuity, the signal value is given by average of signal values taken just before and after the discontinuity. So we'll be taking 1. the average. Second property, unit step is energy or power signal. So it is a power signal. Let's explain how. We have a limit of t tends to infinity 1 by 2t minus t to t x of t whole square. So again putting the value, when we put the value we get the power as half watt and energy as infinite. So the RMS comes out to be 1 by root 2. So this is a power signal. So you remember the step signal is, or the step function is a power function. Again, property number 3 states that the unit step signal is neither even nor odd signal, because if we time reverse it then it will not come equal. So it's neither even nor odd signal. Starting off with ramp signal. Now ramp is given as t to the t at t greater than equal to 0. So it is inclined at 45 degrees with a slope of 1. Now the property is, if we integrate this signal or this function, that is if we integrate step, then we get a ramp. So when the step function is integrated, we'll be getting a ramp function. Unit ramp is neither even nor odd. Both of them will not come out to be equal. Unit ramp is neither power nor energy signal. Both of them are false. Unit parabolic signal. So we know that y square is equal to 4ax. It will be along the axis of symmetric as x axis. Then x square is equal to 4ay. It will be along y axis. X square is equal to minus 4ay. It will be along the y axis. And y square is equal to minus 4ax. It will be along the minus x direction. So the main parabolic function is t square by 2 at t greater than equal to 0. Property number 1 is, if we have a signal that is minus infinity to t, then the answer will be t square by 2. Property number 2 is, it is neither even nor odd. Property number 3, neither power nor energy. Now comes the rectangular function. Its area is always equal to 1. Rectangular function states that from minus a by 2 to a by 2, it will be having a value of 1 by a. So basically the area comes out to be 1. Now the properties. The unit rectangular function is an even signal, that is if we time reverse this signal it will come out to be equal. Property number 2 is, it is an energy signal, that is it has finite energy and power is 0. So energy is finite and power is 0 for rectangular signal. Coming on to the triangular function, t plus 1 from minus t to 0 and t minus t plus 1 to 0 to 1. Here remember, m is always equal to minus or the negative sign on the right hand side and m is equal to positive on the left hand side. Properties, area is equal to half base into height, so half into 2 into 1, that comes out to be 1. Properties are, it is an even signal, so triangular function is an even signal and it is an energy signal. So this was all about the functions, the basic functions that are required to solve the equations. Hope you find this lecture helpful. If you have any doubt, you can always ask me in the comment section below.